Hi, welcome in. I've got an AP Chemistry multiple choice multi-question set today. In the AP Chemistry multiple choice section, some of the questions will just be sort of solo questions by themselves, and then they will also have sort of multi-question sets of maybe 2 to 5 questions. And on the multiple choice section of the AP exam, you get 90 minutes for 60 questions. So that's an average of 1.5 minutes per question. So feel free to give these questions a try on your own before I go through the solutions. And even better, if you'd like time yourself, you can give yourself 4.5 minutes if you want to practice the pace that you'll have on the AP exam. And I'm going to go through the answers in a few seconds myself, and I'm going to do it in under 4.5 minutes myself to get you sort of accustomed to thinking at that pace. So here we go. So we're considering and comparing the elements sodium and magnesium, which are right next to each other horizontally on the periodic table. And so the first question, which element has a larger atomic radius and why? So atomic radius decreases as we go from left to right on the periodic table. And this is because the number of protons increases. Okay, now you might think increasing protons would increase radius, but it actually decreases radius because it increases the charge of the nucleus. And so the nucleus is in the center and is positively charged. The protons have a positive charge, and then the electrons are around it and have a negative charge. So the more protons that are in the nucleus, the more strongly the valence electrons are attracted to them, and they're pulled in closer. So magnesium has what we call a greater effective nuclear charge than sodium because of the additional proton, and so it has a smaller atomic radius. So the answer to number 1 is going to be C. All right, and then number 2 is about first and second ionization energies. So ionization energy is the energy required to remove an electron. So first ionization energy, we're removing the first electron from a neutral atom. And this is essentially going to be inversely proportional to atomic radius, okay? Because atoms with a smaller atomic radius, the electrons will be held more tightly and they'll require more energy to be removed. So we said magnesium has the smaller atomic radius, so it's going to have the larger first ionization energy. In terms of second ionization energy, that's removing the second electron after the first one has already been removed. There's not like a universal trend for that, but we want to think about the valence electrons. So sodium has 1 valence electron, and because of that, its second ionization energy is going to be much higher than its first ionization energy. Second ionization energy is always higher than the first ionization energy, but in case of sodium, it's much higher because the first electron is a valence electron, whereas the second electron is not a valence electron. So that second one's going to be much harder to remove. Whereas magnesium has 2 valence electrons, so the second ionization energy will be higher than the first, but just a little bit, and then it'll have a much larger jump between the second and the third ionization energies. So the correct answer is going to be C for number 2. And then for number 3, we're comparing the chlorides of sodium and magnesium and their respective lattice energies. So lattice energy is related to the ionic compound, to the energy required to essentially break the ionic crystal lattice, which is related to how strong the ionic bonds are. So this is based on Coulomb's law, which says that the attractive force between oppositely charged particles is proportional to the amount of charge they have and inversely proportional to the distance or separation between them, which will be based on the size of the ions. So if we consider their charges, sodium forms a +1 charge, magnesium forms a +2 charge. So magnesium has the greater amount of charge. So that would suggest that magnesium would have the stronger attraction and the higher lattice energy. Now, if we compare sort of the size of the ions, We have to consider how many protons and electrons they both have. Now, the ions both have the same number of electrons. They both have 10 electrons. But once again, sodium has fewer protons, which is going to make it larger, as we talked about with the atomic radius. And so magnesium being smaller is going to have a smaller separation, which also leads to a greater force. So magnesium actually we would predict to have a stronger force based on both of these factors, but the best answer, the only answer that really makes sense among the options is D.